This is a lot more than 5 minutes. A lot more. Before we start, I just want to announce that my 1 hour Clash Royale iceberg is finally out. Trust me, you don't want to miss it. Link in description. Problem 1, the timer. So, how do we get rid of the primary obstacle? The natural 5-minute timer in every game. There is no way to remove it. Thousands of light years away, there are quasars emitting highly concentrated neutron beams. Since these are so far away, the chance of them hitting Earth is pretty much zero. But there is a chance. If one of these beams hit your phone, then it could cause what is known as a soft error. Soft errors cause small malfunctions in the transistors running your electronics. One of these soft errors could cause the one piece of code that governs the timer to malfunction and raise it up to insane levels. According to this guy on the internet, the average electronic gets 2 soft errors a year. If you spend an hour a day, every day playing Clash Royale, the chance of getting a soft error per day is 0.02%. Those aren't great odds, but that's just the chance of a soft error. We need the soft error to change the timer or remove the timer. We will disregard changing the timer since in the scale of this video, no value it could be changed to would be significant enough. Therefore, we will look at the probability of the timer being removed. I don't code, so these are very rough guesses. I'd say that the timer altogether, including the visuals and mechanics, consists of 1,000 lines of code. I might be way off, but this seems reasonable. Big games typically have 500,000 to 10 million lines of code. Since Clash Royale is probably on the smaller end of these big boy games, I'll estimate its line count to be 1 million. Assuming soft errors affect 1,000 lines of code, the chances of this affecting the timer is roughly 0.1%. This is oversimplified, but let's say that if the soft error hits the timer, there's a 1/3 chance it won't do anything, a 1/3 chance it'll add code to the timer section, and a 1/3 chance it'll delete code. Out of the 1,000 lines of code, 5 of them govern the 5-minute timer. Again, this is an estimate, so that's a 0.5% chance. All in all, let's do the math. 0.002 times 0.001 times 0.33 times 0.005 equals 0.00000000165 or 0.000000165% chance to get a soft error that removes the timer, which means it will be an average of 606 million games before you get this. 12 games a day, that means it'll be 50 million days before you experience this, aka 138,000 years. Obviously, we can't set things up during our life, or even the entire lifetime of humanity if we blow ourselves up. But this is one phone. With 138,000 phones, this can be conceivably shortened down to 1 year. I'm sure we'll have a tough time asking the banks to loan us $138 million so we can play Clash Royale, but I'm sure we'll find a way. So, after about a year, we have a Clash Royale game without a timer. You might think we just figured out the key to solving the longest game possible in Clash Royale, but trust me, we are just only scraping the surface. Problem 2, degrading. If we want to run our Clash Royale game for a while, we're going to need to charge it. But with all batteries, they degrade over time. With rechargeable batteries, they last around 3 to 4 years before you need to replace them. However, there's a more immediate problem. Clash Royale will be idling for a long time, meaning you're probably going to leave it on charge for days at a time. This is the easiest way to destroy your phone, rooting both the battery and the charger. If we make a machine that collects the radiated energy from the battery and puts it back into the system and also has a smart tip, which controls battery flow, which stops electron flow when the phone is close to full, we could potentially last a couple of years. If we somehow perfect this machine, consider this problem solved. Problem 3, disasters. Even if you live in a relatively storm-free area, on a scale of thousands of years, one will eventually pass through the room the Clash Royale setup is in, destroying it. You could put the entire setup in the bunker underground, but you would still probably be vulnerable to earthquakes. To prevent this, try being as far away as possible from fault lines. In the US, Florida and North Dakota are your best bet. Although, if we're talking on the scale of thousands or millions of years, continental plates will drift and you might eventually be close to a fault line. Also, if a war or nuclear disaster or anything like that happens near the setup, all bets are off. There are solutions to these problems, but I'll go over that later. Problem 4, the red giant. So then, every problem on Earth is mitigated. We have her set up far underground with a machine that reuses energy with a smart charger that stops charging once the phone reaches 100%, along with the machine that repairs the phone. So then, we wait for 5 billion years. And then, we get sucked into the sun. So, for the people under the age of 8 that don't know what a red giant is, I'll enlighten you. Stars are made from dust and gas accumulating and clumping together due to gravity and nebulas, which are basically stellar nurseries. The gas cloud collapses and the sun is born. The reason the sun has so much energy is nuclear fusion. In this case, hydrogen is converted to helium, which releases light and heat energy. But the sun doesn't have an unlimited amount of hydrogen. In fact, it only has 2 septillion pounds of the stuff. In around 5 billion years, the sun will be close to running out of hydrogen. After that, the sun will be forced to burn helium instead of hydrogen, and that causes it to expand into a red giant, which has a good probability of swallowing the Earth. Imagine you're about to 3-crown someone with your max level mini P.E.K.K.A, and then you got sucked into the sun. True story, by the way. To circumvent this, we need to move really far away from the sun. For that, there's no better place than Sedna. Sedna is so far away from the sun that it takes over 10,000 years to orbit it. When the sun expands into a red giant, no problem. By the way, moving your setup to Sedna also mitigates the disaster problem. While there are probably windstorms and the temperature is literally just above absolute zero, the setup is deep underground, so that shouldn't be a problem. Hopefully. Problem 5. Milkdromeda / stellar encounters. Moving from Earth to Sedna posed a pretty big problem. Sedna is tiny compared to Earth, and is much farther from the sun, so it is easily rocked or even captured by another star. This was a problem since the beginning, but up to this point, stellar encounters are extremely rare. But the Milky Way, our galaxy, and Andromeda, the closest big galaxy, are actually going to collide with each other in 5 billion years. This causes an influx of new stars, and it will probably take a few million years for stars to reach their equilibrium within Milkdromeda. During these millions of years, Sedna could be easily captured by these new stars, perhaps way too close to them, and would be fried. There's no way we can prevent this unless we can literally move our solar system out of the way. But that's impossible. Wait, it is possible. Through something called the stellar engine, you can move the entire solar system. And since, if the sun moves, the planets and asteroids move with it, due to gravity. Okay, so I'm not an astrophysicist, so here's a quote from someone who's smarter than me. A Kaplan thruster, named after astronomer Matthew E. Kaplan, is a type of stellar engine that uses concentrated solar energy to excite certain regions of the outer surface of the star and create beams of solar wind for collection by a multi-bussard ramjet assembly, producing directed plasma to stabilize its orbit and jets of oxygen-14 to push the star. The buzzard engine uses 1,015 grams a second of solar material to produce a maximum acceleration of 10 to the power of 9 meters per second squared, yielding a velocity of 200 kilometers per second after 5 million years, and a distance of 10 parsecs after 1 million years. While theoretically the buzzard engine would work for 100 million years, given the mass loss rate of the sun, Kaplan deems 10 million years to be sufficient for a stellar collision avoidance. With the Kaplan thruster, we can avoid any stellar counter that comes our way. Intermission. So now, we play the waiting game. Let's go over our entire setup. Around the sun, we build the Kaplan thruster. We go to the far reaches of the solar system to Sedna and drill a hole underground and construct a bunker. In the bunker, we essentially create a perpetual motion machine and smart charger. And then, Clash Royale itself. The sun whisks away into a white dwarf, freezing the solar system. The 71 galaxies in the galactic local group coalesce into one huge mega-galaxy. The universe gets bigger and bigger, making everything millions of light years apart. We will be a cold, isolated speck in the grand scale of our reality. The universe becomes depleted of the gases needed to form protostars, and so stellar production ends. Sedna eventually gets kicked out from the solar system through gravitational decay. All remaining stellar remnants, like white dwarfs or neutron stars, are ejected from galaxies. Sedna is a rogue planet, all by itself, while the universe goes dark. except for our Clash Royale game. Problem 6, Proton Decay. Before we talk about Proton Decay, let's just visualize how much time passed between Milkdromeda and now. We are at 100 duodecillion years, a number with 41 zeros. Before, we were only at around a billion, meaning we have multiplied our time by over a decillion. Now, what is Proton Decay? I'm not an astrophysicist, so here's a quote from someone smarter than me. In particle physics, proton decay is a hypothetical form of particle decay in which the proton decays into lighter subatomic particles such as a neutron, pion, and a positron. The proton decay hypothesis was first formed by Andrei Sakharov in 1967. Despite significant experimental effort, proton decay has never been observed. According to the standard model, the proton, a type of baryon, is stable because baryon number, quark number, is conserved under normal circumstances. See chiral anomaly for exception. Therefore, protons will not decay into other particles on its own, because they are the lightest and therefore least energetic baryon. Positron emission, a form of radioactive decay, which sees a proton become a neutron, is not proton decay, since the proton interacts with other particles within the atom. Some beyond the standard model grand unified theories, GUTs, explicitly break the baryon number symmetry, allowing protons to decay by the Higgs particle, magnetic monopolies, or new X bosons. Wow, I became 200 IQ just reading that. Anyway, I want to emphasize the word hypothetical. If protons do decay, then we're kind of screwed because a phone probably needs its protons to work properly. But if proton decay is false, then we're saved. Next problem. Problem 7, black holes. By this time, we have finished the Silliferous era of the universe and have entered the degenerate era. Here, the majority of the universe consists of black holes. So, by random chance, our setup could be sucked into a black hole, which is obviously a problem. There is no known way to destroy black holes, but we could make another black hole out of antimatter. This would cost $2 trillion to get all the materials needed to create the anti-black hole, which is a number with 41 zeros, but it's all worth it for the sake of science. So, we need another machine that can detect when a black hole is close, spew octillions of pounds of anti-hydrogen, and have it collapse into an anti-black hole, and then when a black hole and anti-black hole collide, they annihilate each other. Problem 8, quantum tunneling. After 100 vigintillion years, there was a 99% chance that one of the atoms in this setup quantum tunneled to somewhere else, maybe even into a black hole. By the way, 100 vigintillion is almost how many cookies I have in Cookie Clicker. Similar to proton decay, if quantum tunneling is possible, we're kinda screwed. A phone probably needs its atoms to work. Again, tunneling is hypothetical. Even if it is possible, there is a solution, but it makes sense if I tell you later. Problem 9, the end of the universe. In 10 to the power of 10 to the power of 120 years, by the way, that is way more than a googolplex, the universe will be destroyed. How? I won't go over it, but several theories are big death, big rip, big freeze, big crunch, big slurp, big bounce, and false vacuum. That's a lot of bigs. So, there's no way we can get around this unless we can literally escape the universe, but that's impossible. Wait, it is possible. If the Omniverse theory is correct, then that means there are cosmic strings connecting parallel universes. By the way, the name of this channel is a coincidence, but you should subscribe to the Omniverse nevertheless. Physicists have made models on how to open wormholes, but every possibility so far is extremely unstable, with the wormhole closing faster than the speed of light. Exotic matter, which has a negative mass, could be used to prop the wormhole open, but that probably doesn't exist. However, by a googolplex years, humanity would probably be technologically advanced enough to create a trans-multiversal wormhole. This solves problems 6 and 8, because we might warp to universes where those laws of physics that govern proton decay and quantum tunneling don't exist. The end of the Omniverse. According to chaotic inflation theory, there are 10 to the power of 10 to the power of 10 to the power of 7 universes. Assuming each universe lasts 10 to the power of 10 to the power of 120 years, yeah, we got a huge number on our hands. In total, the longest Clash Royale game is 10 to the power of 10 to the power of 10,120 years long. There literally isn't enough space in the universe to write out the exponent, let alone the actual number. This is so big, the entire Omniverse itself literally is not enough to put into scale how gargantuan this number truly is. Conclusion. For the game to be a full game, it must eventually end. And I don't think that having the game end by the literal entire fabric of reality being ripped around counts. So, 5 minutes before the last of the 10 to the 10 to the 10 to the 7 universes completes its 10 to the 10 to the 120 years, it's programmed to start beating the game. For the first time in literally forever, a max level mini-pet is deployed and it's refound. This is the last relic of human civilization. If the Omniverse is a simulation, maybe the people running the simulation will be so impressed in our dedication to Clash Royale that they will give humanity a second chance. We have literally spent trillions of dollars and time so high it literally wouldn't fit in the universe for a mobile game. And you know, that's the admirable thing about humanity. They don't know when to stop. If they have a goal in mind, they will see that they accomplish it. Even if it is in 10 to the 10 to the 10,120 years, they will get the last laugh. This video was so fun to make. As a growing Clash Royale content creator, I want to establish myself as revolutionary. There are a lot of great Clash Royale YouTubers, but they all have the same type of content. Deck showcases, pro tips, or just gameplay. I'm nowhere near as good as them, so I want to take Clash Royale YouTube in a different direction, which my 1 hour Clash Royale iceberg and this video have started. A lot of people don't recognize how deep this game is. This is the start of a revolution. If you want to start me on this journey, please subscribe. I have some insane Clash Royale content just like this video in the works, and trust me, you do not want to miss them. I'll see you in the next one. This is the Omniverse signing out.